where, as we know, if at first you don't succeed, try again. But not to say that you just try the same exact method over and over and over. You want to, try, reevaluate, and then try again, I think. But yeah, today we're going to be continuing on with the LeetCode adventure via NeetCode. And as of the last video, we got 11 questions down. We're still kind of going through our easy question spree here. But honestly, I want to check out one of the tree questions. So I'm just gonna pretend that the wheel landed on trees because I've not yet gotten into this section at all, and I'm really curious about it. So I'm thinking this video might just be a bit of a research expedition. But yeah. So given the roots of two trees, return true if the trees are equivalent, otherwise return false. Okay, if the nodes have the same value and they have the same structure. Ooh, interesting. Okay. Q is 4, null, 7. Yeah, I'll put false. Okay, and each item has this dot left, this dot right. Okay, cool. Oven time, oven space. Great. All right. Oven. So ov2n is oven if we have two different trees or whatever the case is. So I'm thinking for this one that we could pop everything into two different queues, which I usually, as an aside, just use arrays for both queues and stacks, with a stack being like a stack of plates in a dispenser, so first in, first last out. Sorry, the things you put in first go to the bottom, so you can't take them out past the other plates on top of them. But a queue is like a line in a bank, so if you go in first, you're probably going to get served first unless something weird's going on in that bank. So constructor with a value, we have a left or right with the value. Yeah, that is that item. So yeah. Okay, so these are the nodes. I'm just trying to get an understanding of what's going on here. So P is 4, 7, Q is that. Okay, yeah, so our params are giving us the tree node P and tree node Q. Okay. Given the roots, give blah blah blah, return. Okay, well, here's how I am thinking of doing this. So we have our two trees here, let's say for case one. So what I'm thinking is we could do whichever traversal we end up writing, right? So what we'll do to traverse a tree is 1, 2, 3. We'll say and I'm not sure which one we're gonna do yet, but let's say we just do a level order traversal here, just for the sake of drawing things out. So we'll put the things into an array. And then we'll let's see, is it shift or unshift? I think I told myself unshift is moving everything in because you have to squeeze them all together, and unshift and squeeze, S-Q-U-E-E-Z-E, both have U's in them. But then shift is if you need to shift everything forward. So it'll be array, oops, or what we'll want to see anyway is array 1 dot shift equals array 2 dot shift, and loop through these arrays, checking that. First is in the case where it's 4, 7 versus 4, null, 7. in like the second iteration, you'll get 7 equals, which isn't equal to null. And so then we'll try to return, return false. All right, so let's see if we can code something like this, shall we? And then we want O(n), right? So that means that we can loop through things multiple times, but we should not loop through things in like a nested for loop. So we can try to do that. Okay, so here we could do let array p equal this empty array, and then, or actually, it should be the root node. I'll come back to that in a second, sorry. So let array q equal this empty array. I wonder, this dot value is just supposed to be the first value. How do I loop through things? Let's find out. I want to console log to find out, like a print statement. Key dot value? Like, what is the first thing here? Like, I'm wondering if this is going to give us back the first node. Yeah, no. Okay. So, 0? Okay. We don't like that it's value. Great. In console log p. Did it time out? Oh, wow. Okay, here we go. Oh, wow. Okay. Tree node. Val is 1. Okay, yeah, so it's telling us when we console log p, we get the first value, and then we could do like p dot left and get this. Oh, cool. Okay. And p dot right is this. Wow, fascinating. Okay, cool. So, yeah, wow. Okay. Let's see. What do we want to compare in here? I think it would be useful for us to just compare the values, honestly. I don't think we need the whole situations. So, because like we're not adjusting the arrays that we're given, so. First of all, I'm like, can we do the q dot length for these, the tree dot lengths? No, I don't think so. Let's see though. Yeah, no, okay. Okay. Okay, I mean, for some reason I'm hearing in my head that we should do a while loop, but then I'm like not 100% sure how we could make sure that like that we got through everything, if that makes sense. O of n, time and space, where n is the number of nodes in the tree. Okay. let's just run through it a bunch of times. I mean, because yeah, I guess excuse me. Worst case, we go through, and then it's like O of n plus n if n isn't the same as n. So like you go through the bigger tree essentially, but like they should be the same. So yeah, like let's do that. So while okay, let's try that. Excuse me. Yeah. So while p is not p dot value is not null, and then first of all console log p dot val so I can see what's going on. Then also a p dot push p dot val, and then we want to do this operation on the left and the right nodes. So p dot val equals p dot left, and p dot val equals p dot. I don't know if this is written properly, but one way to find out, I think. Oh man. Oh, hey, okay, wait. We didn't just get all timeouts. That's cool, okay. Okay, so we know that we first wanted, we had this anyway. We put in p dot val. So I think this should be yeah. We need some if loops to prevent it from like jumping into the tunnel if the tunnel value is null, because that's what's like airing out our code. So like if sorry, so if p dot left is not null, then it's in there. This, the other side is not null. P dot right is not null, then p dot val is p dot right. I think I'm supposed to be putting this stuff into a queue to have it actually run through what it's supposed to do here. But I'm taking a stab at this, and then I'll take a break and do some research. Whew, man, that is not looking promising. So JavaScript, iterate through tree recursively. Yeah, okay. Oh wow, none of these went through this time. Fun. Wow, wow. Creating trees here, searching. Yeah, they do visited arrays, okay, and a queue. Pushing the current while there's the, yeah. And then like, based on this, which is breadth for search, every item left to right, level. Okay, yeah, so level order traversal, that's what we wanted to do. So they have a visited array, which in our case, we could do a values array to, you know, let it, oh my gosh, we were actually kind of close here though with this if block. Yeah, if there's a left, push it. If there's a right, push it. And okay, while the queue is not empty, yeah, and start off with pushing it. Okay, hey, nothing like being on the right track. Like, that's actually really nice. So, let's see. Except we're gonna have to do this twice, one each per both tree things. I wonder, like, here's my little, like, JavaScript notes list here where I've been putting items into. So, like, I'm wondering if we have two, or something to see if, like, two arrays are equal. Shift, unshift, flat map. Really curious about that, actually. So, let's see, return array equals array. Like, I wonder if this, sorry. What was that? Okay. Okay, well, am I supposed to be going somewhere? Yes. Do I want to solve this problem a little bit more? Yes. Cool. Okay. Yeah, so we could just do like if these two arrays equal each other, if we put their values into the arrays. So that's really cool, I think. Also, we could probably reuse the same queue. So let queue equal this other array. Or I could call this like traversal queue. Traverse P. Or I should do traverse QP. Yeah, and then traverse QQ. Great. I like those names of things. These are going to be our value arrays instead of array. Values in P and values in Q. Just going to clean this up here. Okay, so we're going to rewrite this. So what we're going to do is we're going to two lines, do the same thing essentially. Oh, sorry. Okay. Yeah, I can do that. So we have traverse Q, and then we'll put in the respective letters, dot push, and then we'll put in the respective letters again. So in traverse QP, we'll push P, and in traverse QQ, we'll push Q, which is the node, the root nodes for both of them. And then we'll set up some while loops, but then we'll be looking at this not being empty. So while traverse Q, or let me do it this way since we're doing double type here. So yeah, while traverse Q, and then we'll put the letters, dot length, it's not 0. So while the traverse Q still has something left to traverse, we'll put the value of the item into P. So I think it's p.val, like whatever we're at .val. Yeah. You take a little break here and put the letters in so it's a little easier to see. This one is Q, actually. Yeah, and then values in, and then whichever letter, dot push, and then whichever letter. So I'm just going to put P's in for now, and then come back and fix this one. Okay, so now we have put the value in. Console log set value. So that way I can get that little look-see of what's going on. And then we'll push the next children, if they exist, into the traverse queue. So if whatever, so I'll put in P and adjust it down here, dot left, need some parentheses, so P dot left, then we'll push the next into the traverse queue. Traverse queue, P dot push, P dot left, and then you need to have a semicolon if we're trying to do one-line if statements to be fancy, like we see the pros doing. And then if right node, we want to push that right node into the queue that we're traversing as well, like for whatever is next. So then turning our P's into Q's here, like the saying, mind your P's and Q's. Wow, actually, how interesting. Those are our values. Anyway. Okay, great. All right. Just removing the dead code there. Okay, and then console log for myself, values in P and values in Q. All right, let's run it and see what all happens. Okay, I messed up some capitalization. That's to me. The length of this, oh man, it's making me. Oh wait, Q dot shift. Oh yeah, I'm supposed to do that. Whoops. Yeah, because then how else would it know that we're taking the first value and like what we're operating on? Okay. Is it a dot push? Okay, that makes sense about why I was like confused. So like we have to have a current so that we can know what we're doing. Let P. Ugh, man. I'll go through and fix them. Haha, nice. I'm just adjusting all of these so that we can have that current item that we're looking at and set that equal to something equal. So, okay, when we're traversing something, we need to like, well, let's explain what's going on here. So let's say this is our tree. We have to have this array of like items that we're gonna interact with, let's say. So like if this is 1, this is 2, this is 3. Essentially, the first thing we're gonna do is put this 1 into the array because that is the same as like our tree. That's when we're saying this at the beginning, traverse q dot push p. So what's going on when we do that is we put the tree root into our traverse queue, and our traverse queue is the items that we have not yet visited, so or like interacted with. So at the beginning we put the root node into what we've not yet interacted with, and then in this while loop, since 1 is in here now, we say like let's interact with it. And when we do that, we push in the left value and the right value into here, like the children, I guess, of number 1, but we have removed number 1 when we interacted with it. So then what happens is like 2 goes into the interaction loop. If 2 had any children, we'd push the right and left into there, but we would have taken 2 out to interact with it. And then 3 would be left. We take it out when we interact with it. We push any children into the array, because like say our interaction thing is down here, like our interaction block. So yeah, that's what's happening. It's like it was 1, then as we go back into the while loop again, it gets reset to 2, and then as we go back in there again, it gets reset to 3, so on and so forth. So by looking at the code, which is, I guess, how when people solve these problems again and again, they just know that's what you need to do. But anyway, it's like that helps us like get to, you know, see where we are, what's next, etc. So anyway, p.current is going to be this array's whatever is first in there, so that is traverse q p dot, I think we said shift is pulling stuff out of the front. And then we're going to have to do that here as well. Q current is traverse QQ, first item, and then the other thing we're going to need to do is p current dot value, and here Q current dot val. Okay, great. And then here I want to see the value as well, because I can only see things through print statements. But honestly, since we're printing the arrays, and since we actually have something that makes sense in terms of getting the first items, I'm like kind of thinking that we should be okay. Just seeing the overall thing here. Okay, so, ooh, okay. All right, so yeah, we're console logging p still here, which, you know, no need to do that anymore, which is giving us this tree value situation. This is the arrays. That's interesting. All right, well, I mean, for some reason this isn't working, but let's see, this one is false. Oh, it's always returning false. How fun. Okay. I think that could just be because they're different arrays. But I wonder if there's a way to do that. JS array compare values. Oh, I guess they converted to strings. Yeah. Yeah. And like my theory for that came because, you know, even here, or here, like they're different colors, so that's telling me like while the values are the same, it's not like getting all the, or it's not looking at these two items as being the same. So like I'm wondering if I have any like toString situations in here. It's in the bitmath section. Yeah, toString. Great. Creates a comma separated list of elements from the array. Fantastic. So we can do, okay, array value p and array value q dot toString. Great. And like look at the string values of these two things. See if they're the same. Okay, one step closer. Nice, very nice. Okay, ooh, okay. Oh gosh, okay, null doesn't come out into strings here. What can we do about that? I wonder what the lengths of these are, since one of them has a null. Man, okay. Okay, I'm like wondering if hints say anything. Oh my gosh, recursion. Is that the, can you think of a way to simultaneously traverse both trees? Is that a thing? Starting from the roots, at each step in the recursion, we check if the current nodes in the tree are either null. If one node is null and the other is not, or if their values differ, we return false. If the values match, we check both of them. Okay. If any recursive call returns false, the value for the recursive call is false. Okay, I'm like, that's not the question I had, but like, I get what they're saying. So I'm not gonna rewrite this all right in this moment though. So while we traverse, okay, I'm gonna do a little bit of research. Please hold. But thanks in advance to algo.js, who does great videos explaining how to do these, and I'll see you back here in just a sec.
Hey everyone, welcome. Individual node of both p dot right, q dot right, and this will create.
So they're doing the thing that the hint said to do, which is fine. I'm just looking to write some code that's different. Let's see here. Okay, we're coming back. So, like, while I understand that they want us to, write a lot less code, do it in one situation, etc., I'm like wanting to say that, okay, and the values could be negative, whatever here, all right. Let's see. I'm wanting to say like if the value is null, I want to push in the string null. Else put in this value. If current value is null, and then use in p.push just this string null, and that should help us get around the whole null disappearing situation, you know? And then when we come and rewrite this equation, we can do it the quote-unquote right way, or the more direct, more efficient way, where we just, I guess, write it recursively. And I mean, that would be really good recursive practice as well, I suppose. How is this? What is happening here? Okay, what am I currently console logging? This is not super helpful. Oh, I should be console logging this. Console log these things. So I would like to see, I would like to know what the values of these strings are. Great. No, it didn't do my null. I wonder if I could put this in an array or something. Like, I just need it to be like a disruptor, you know? Oh, you know what? This is saying if blah blah blah. But yeah, because we're not going to visit a thing that's null is the problem. Okay, I'm gathering more and more why they want us to do it the recursive way. Okay, let's give it a stab on the next stream, just because I do have somewhere I need to be getting to. But I'll put that on the to-do list. Try, which problem is this? Same binary tree, again, recursively. Okay, so wait a minute, actually before I like make my code go away though, I'm like, wanting to say to these like, hey, if it says the value is null, push null into the values array. Actually, I could do that here. Maybe not current value, but I could probably do it here before the left and right. Yeah. Yeah. Because that way it'll like tell us if p dot, oops. So this is p dot current dot value, p dot current dot left is null, then in our holder array we could put that. And if the right value is null, then there we could put that. And then this one could be here. This one could be here. Oops, we don't need that array thing that I was messing around with though. Just need the string. And then need left is null, then we can do that. And if right dot null, we could put it in there. So let's take a little look-see. Oh my gosh, case 2. 4 null, 7 null null. That is so weird. Because what I'm expecting is like 4, like what does this mean, null? So I'm just gonna adjust these so that way it's like very clear. Because I think that might help. It's funny because I'm just like digging into a hole and going like deeper and deeper, but yeah, so this is telling us now like which exact thing is null. Yeah, so are we on case 2? Let's go back to case 2. Okay, yeah, so 4, in this case, the right side is null, and in this case, the left side is null, and then 7 has null for both. That is what we're expecting. Okay, good. Yeah, so in terms of time complexity, oh no. Let's see, okay. Yeah, we need a empty checker here. I thought, though, that it had said that we were always gonna get values in. I guess not. 0 less than or equal to. Okay. So if P and Q, or P equals null and Q equals null, return true. And then if P equals null, and then here's from, thank you very much, AlgoJS, but you could do or, and now we know how to write an or properly. Q equals null, return false. Okay, just as our like starting condition or one of them. And then this should actually work. Hopefully, fingers crossed. Yes! Okay, so what are the final thoughts of this equation? So we do traverse both trees still. We do them in separate while loops instead of in one while loop. So it, like O of 5 n, for example, and O of n are the same because we dropped the constants. So like theoretically, it's still running in O of n time complexity. I think they said O of n space complexity as well. Right, great. So since we're doing queues and storing the values in an array or arrays, it's O of n space complexity. Similarly to the ideal solution, the ideal solution seems to be a recursive call, whereas they say in the hints we would traverse the trees, check if both items on both trees are equal at the same time. So yeah, this is a little bit brute forcey, but you know, if it works. And today on Try It Again Dev, we tried it again until our code compiled. So hey, a win is a win. So thank you so much for joining. If you're watching, this is just to show that like people don't start off as like LeetCode masters. We start somewhere. We all have to start somewhere. This is what realistic learning based on solving problems looks like. And if you are joining with any tips, tricks, and you pop them in the chat, I would love to take those in, take those suggestions, and move forward with them. But yeah, thank you so much for the support, and see you next time here on Try Again Dev.